Hi everyone. In dimensions and calculations, our today's topic is volume calculation. Volume means how much space something takes or how much it can hold. For example, we have a glass. So what is the capacity of this glass? Meaning how much water the given glass can hold. Similarly, there are two boxes, big box and small box. So, which box can hold more things, big one or smaller one? Therefore, volume is the amount of space an object or substance occupies. Volume is about 3D shapes. Today we will learn how to calculate the volume of common 3D objects we use in daily life. Now we know that volume tells us how much space something takes. So let's learn how to calculate the volume of everyday 3D shapes like boxes, bottles and cans. Here the common geometric shapes include cuboid, cube, cylinder, cone, pyramid and sphere. Let's explain these one by one in detail. Our first shape for volume calculation is the cuboid. This shape, a rectangular shape. In our daily life, we see many cuboid shapes object like shoebox, cupboards, tissue box, a phone book, a photo frame, etc. The formula for the volume calculation of the cuboid is equal to, that is, volume is represented with V and V is equal to length into width into height. So if this side is of length and this side is of width or breadth, then this will be considered as height, and then multiplying all the three, so we get volume of the cuboid. Our next shape is the cube, this one. So you already see cubes around you every day, like cube-like shapes include dice used in game like playing Ludo, gift box, salt crystals, ice cube, etc. The shape like cube type is called cube shape or cube in geometric shapes. So the volume for calculation of cube is the simplest one, is its length, width and height are all same. Therefore just take the cube of a side. Let's suppose a side is represented with A. This is equal to A, suppose. Then this will be A and the height will be A. And multiply A 3 times. So we will get the volume of a cube. Our next 3D shape is cylinder. Our routine used shapes which looks like cylinder include can of soda, glass, battery, glue stick, thermos or coffee mug, etc. Now to calculate the volume of cylinder, we proceed like this. Here volume is equal to circle area into height. This portion is of circle area. This is the center point, this is the radius. So circle area is equal to pi r square, but multiply h with it. This is another, and then consider the height, which is called h. So circle area multiplied by height will give you the volume of cylindrical shapes. Our next 3D shape is the cone. We see cone in ice cream cones, party hats, traffic cone, etc. To calculate the volume of the cone, the formula will be volume is equal to 1 by 3 pi r square h. That is, the volume of the cone is 1 by 3 of the cylinder. This is 1 by 3 and this is cylinder formula. So volume of the cone is 1 by 3 of the cylinder. Our next shape is pyramid. You see, or you have seen, Egyptian pyramid that looks like this shape. Similarly, tent shape is like this, or some house roofs are like this. So when you want to calculate the pyramid, the volume of the pyramid, so the formula will be volume is equal to 1 by 3 base into height. Base into height. Now see the base of the pyramid. A pyramid is a 3D shape this is the base, and it has triangles which meet at a point on the top. So a pyramid is of square base where length is equal to width, and finally divided by 3. So this will give us this formula. The shape of this pyramid according to this base area and height will form this formula. Our next shape is sphere. Sphere looks like balls, like tennis ball, baseball, and fruits like oranges, melons, lemons. Like fruits are imperfect spheres. And in food you see meatballs, cheese balls, planets and the sun are of shape of spheres. So the formula for the volume calculation of the sphere is equal to 4 divided by 3 pi r cube is we can see that all other shapes have edges, but a sphere have no edge. All other shapes touches the ground completely, but sphere isn't touching the ground completely. We can also see that the cylinder is of curved shape. So it has a radius. Similarly, a sphere has a radius. When the radius of the cylinder and radius of the sphere are of same size, then we can fit this sphere into the cylinder, or the sphere could be easily fitted in the cylinder like this. So here in this case, radius of the sphere and radius of the cylinder are of same size, so this sphere is inside this cylinder now. Now let the height of the cylinder is equal to the height of the sphere. This height of the cylinder is equal to the height of the sphere. So the height of the sphere is actually the diameter of the sphere. So height will be equal to 2 into radius, where 2 into radius is the diameter. Now the curved surface area of sphere is equal to the circumference of the circle into height. So the circumference of the circle is 2 pi r and the height is 2 r, which makes 4 pi r square. Now if you see the sphere, then its outer space is made up of many crystals, like you can call it a pyramid. Like if you combine these pyramids, like these squares like this, this is one pyramid shape, this is another one, and this is another one, and when you combine it, then this will give this spherical shape. Now if we consider that suppose this shape is made up of let's take 100 pyramids, like suppose we say that this sphere is made up of 100 pyramids, then the volume of pyramid is equal to 1/3 base into height. Now let's place this height with r, because the radius of the sphere and the height is the same. So volume will be equal to 1/3 b into r. Now as we said that this shape is made up of 100 pyramids, so we will add them all. 1/3 common, r common, and inside will left b1 plus base of the first pyramid, then base of the second pyramid, and so on up to base of the 100th pyramid. Now this all 1/3 are this whole portion from base 1 to base 100 is the whole surface area of the sphere, which was this 4 pi r square. So hence the volume of the sphere is derived from the volume of the pyramid by incorporating the circumference
area
of the
sphere.
Now here I have mentioned some exercise. For cuboid, you use this question. For cube, use this information. For cylinder, for cone, for pyramid of square base, and for sphere, and then solve these questions with the help of above formulas. Thank you.